Hi, my name is Erica Warkus. I'm doing my MD PhD research at the University of Hawaii John A. Burns School of Medicine. In my research, I'm creating a stem cell-based test to detect drugs that cause birth defects, also known as teratogens.
The majority of birth defects are caused during the first 3 to 8 weeks of development, when the embryonic body plan is laid out and organs begin to form. This process, called morphogenesis, happens when the embryo is only a little larger than your thumbnail, so it is very difficult to study the effects of teratogens in mammalian pregnancies. Currently, the FDA requires that new medications undergo many rounds of developmental toxicity testing in vivo, using live lab animals. As a result, developmental toxicity testing has some of the highest rates of live animal usage in research. Therefore, there is substantial interest in the development of an in vitro screening assay able to easily and accurately identify teratogens. A number of promising in vitro tests have been proposed, but nearly all of them look at survival and differentiation of a single cell type, such as osteoblasts, cardiomyocytes, or neural precursors. Unfortunately, this limited assessment may give an incomplete picture of teratogenic effects in humans.
To model in vivo effects, a teratogen screening assay should evaluate adverse impacts on complex three-dimensional aspects, such as body patterning and morphogenesis, rather than just measuring cell survival and differentiation. The P19C5 cells are absolutely unique because they are able to recreate the three-dimensional process of embryonic morphogenesis in vitro, something no other stem cell line in the world can do.
The objective of my dissertation project is to use the P19C5 in vitro morphogenesis to create a screening test for teratogenic chemicals. In my research, I make cellular aggregates called embryoid bodies, each of which starts as a small clump of about 200 cells in a droplet hanging from the lid of a petri dish. Over the course of 4 days, the cells making up each embryoid body organize, differentiate, and establish a craniocaudal axis before elongating in a way that closely resembles the process of embryonic morphogenesis. The best part is that when the EBs are treated with a chemical capable of disrupting embryonic development in vivo, they show abnormal growth and elongation. By looking at the comprehensive process of morphogenesis, we are able to investigate the effects of developmental toxicants at the earliest stages of embryonic development.
We hope that this assay will complement the EST and other in vitro screening assays in order to significantly reduce the number of animals sacrificed for developmental toxicity testing in the U.S. We are very grateful to IFER for their support towards this goal. Thank you.